Imagine drifting through the dark, weightless, with nothing but the faint hum of the universe in your ears. Out here, everything is impossibly large and impossibly old. The cosmos stretches in every direction, 13.8 billion years deep, 93 billion light years wide, and still growing. Countless galaxies drift like glowing islands in an endless black ocean. Each one holds hundreds of billions of stars, and around many of those stars spin worlds we will never touch. Some burn with quiet blue fire. Others are cold, dead cinders. A few, maybe one in a billion, carry the soft whisper of life. Tonight, let your mind wander across that vastness. Let the numbers wash over you until they feel like a lullaby. Because out here, in the silence between heartbeats, the universe is telling its oldest story, and you're finally close enough to hear it. Begin with a single star, our star, a perfectly ordinary yellow dwarf, one of 100 billion in the Milky Way alone. Every second, it turns 8 million tons of hydrogen into pure light. That light takes 8 minutes to reach us, so when you look at the sun, you're seeing it as it was when your morning coffee was still hot. Travel farther out, past the orbit of Pluto, and you reach the edge of its kingdom, the heliopause, where the sun's breath finally gives out and the true dark begins. Beyond that boundary, the space between stars isn't empty. It's filled with a thin soup of stray atoms, one lonely hydrogen every cubic centimeter. In one breath, you could inhale more atoms than there are stars in the observable universe, yet you'd never notice. That's how empty the dark really is. And yet, in that emptiness, entire galaxies collide without making a sound. The antenna galaxies, two spirals locked in a slow-motion embrace, are tearing each other apart right now. In a billion years, they'll merge into one giant ellipse, their black holes dancing closer until they too become one. No one will be there to watch. No one needs to be. The universe doesn't perform for an audience. Now fall deeper, past the Milky Way, past the local group, until you reach the Laniakea supercluster, our home address among the megastructures. Laniakea is a web of 100,000 galaxies pulled together by gravity, stretching 520 million light-years across. At its heart lies the Great Attractor, an invisible mass so powerful it drags everything, us included, toward it at 2 million miles per hour. We don't know what it is. Maybe a knot of dark matter, maybe something stranger. We only know we're falling toward it and always will be. Zoom out farther still, and the universe starts to look like foam, bubbles of galaxies separated by vast voids 100 million light-years wide. Stand inside one of those voids, and you'd see almost nothing. No stars close enough to twinkle, just a faint glow on the horizon, the combined light of every galaxy that ever was, arriving billions of years late. That light has been traveling so long that the galaxies that sent it no longer exist in the form you see. You'd be looking at ghosts, trillions of them, painted across the sky like a memory the universe can't quite let go of. And somewhere in all that darkness, on a pale blue dot, orbiting an average star in an unremarkable galaxy, something impossible happened. Carbon, hydrogen, oxygen, ordinary stardust learned to want. It learned to fear the dark. It learned to ask why. That speck of dust built machines that could listen to the echo of the Big Bang itself, A whisper, 13.8 billion years old, still arriving from every direction at once. It found ripples in space-time left by colliding black holes a billion light years away. It watched the star explode and realized the gold in a wedding ring was born in that final, furious heartbeat. Every atom in your body was once inside a star that died so you could be here tonight. The universe took 13.8 billion years to make the iron in your blood, the calcium in your bones, the spark behind your eyes. And now, you're using that spark to look back at it and wonder what it all means. Maybe that's the quietest miracle of all. The universe, vast and cold and mostly empty, somehow grew minds that could feel small beneath it and still choose to stay awake just to watch it breathe. So close your eyes now. Let the darkness feel gentle. Out there, 100 billion galaxies keep turning. Black holes sing in gravitational waves no ear will ever hear. Stars are born and die without applause.
Beyond Neptune, the sunlight is only 1,000th as strong as it is on Earth. A pale silver coin too weak to cast real shadows. Yet in that dimness, an entire country of ice still glitters. The Kuiper Belt begins here, a broad, dark ribbon of frozen worlds that never grew up. Thousands of them are larger than cities. Hundreds could swallow continents. All of them move in slow, perfect silence, locked in orbits that take 2 or 3 human lifetimes to finish one lazy circle. Pluto drifts among them like a defiant child who refused to leave the party. Its surface is a patchwork of gold and rust and blinding white. The great heart-shaped plain, Tumba Regio, is not rock at all, but a glacier of solid nitrogen, methane, and carbon monoxide that creeps a few centimeters every year, pushed by gentle heat from below. Towering above it rise the water-ice mountains of Hilary Montes, sharp as broken glass because no wind has ever softened their edges. Some peaks are taller than anything on Earth, yet they stand on a world so small you could walk across it in a long weekend if your boots could grip the ice. Every few centuries, Pluto swings a little closer to the sun, and a thin sky appears. Blue haze only a few miles deep, so fragile that sunrise looks like a match struck in a cathedral. Then it turns away again, and the sky rains back onto the ground, molecule by molecule, until the air itself becomes frost. Charon hangs overhead, forever full, forever locked in the same face, a gray moon scarred by chasms deeper than the Grand Canyon. Between them, the center of gravity floats in empty space. They orbit each other like slow dancers who forgot the music ended billions of years ago. 4 smaller moons, Styx, Nix, Kerberos, Hydra, tumble chaotically nearby, spinning and flipping whenever Charon's tides nudge them. No one calms them, no one needs to. Out here, chaos is just another kind of order. And beneath Pluto's frozen skin, something warm may still be breathing. Seismic data hint at a buried ocean, liquid water kept from freezing by the gentle flexing of radioactive decay and tidal love. If it exists, it has been dark for 4 billion years, darker than any cave on Earth, yet possibly richer in chemistry than the primordial soup that once boiled on our own world. Pluto is not the end of anything. It is a promise whispered in the coldest place the sun still claims. Imagine a sphere so large that light itself takes 2 years to cross it. That is the Oort cloud, the solar system's forgotten attic, a hollow shell of ancient ice surrounding everything we know. It begins roughly where the Kuiper Belt peters out and stretches almost halfway to the nearest star. Trillions of comets sleep inside it, each one a dirty snowball no bigger than a city, packed with frozen gases and the carbon chemistry that would one day learn to dream. Most will never wake. They drift in perfect cold, untouched since the sun was a baby and the giant planets were still bullying their way into position. But every few million years, a star drifts past the edge of the cloud, close enough that its gravity strokes the sleeping comets like fingers across harp strings. One of them trembles, its orbit tilts. It begins the long fall inward. For 10,000 years it falls alone, gathering speed, ice creaking as the first warmth in eternity seeps through. When it finally sweeps past the outer planets, its surface erupts. Water, carbon monoxide, methane, all the fragile ices that have never seen sunlight turn straight into glowing gas. A coma swells around the nucleus, a shimmering sphere larger than Jupiter. 2 tails unfurl, one of pale dust that curves like silk in a wind no one feels, one of straight blue ion glow pushed by the sun's magnetic breath. Some tails stretch farther than the distance between Earth and Sun. On Earth, people step outside and gasp at a comet so bright it casts shadows at midnight. They make wishes. They take photographs. They have no idea the comet has been traveling since the mammoths walked and will never come this way again. When it rounds the sun, it is flung outward forever, stripped of half its mass, a burned-out husk doomed to wander interstellar space until another star claims it millions of years from now. The Oort cloud never mourns the ones it loses. It simply closes the gap, and the dark grows quiet again. Between the neat orbits of the Kuiper Belt and the wild chaos of the Oort cloud lies a no-man's land of broken orbits, the scattered disk. Here live the exiles, worlds that were born in the warm cradle near Jupiter and Saturn, only to be kicked screaming into the cold when the giant planets rearranged the furniture 4 billion years ago. Eris, brightest and most bitter of them all, is actually larger than Pluto and twice as far out, a diamond-hard ice ball coated in frozen methane that glitters like snow under a full moon that will never rise. It takes 557 years for one orbit, a slow, angry waltz no one invited it to. Sedna drifts even farther, blood-red and mysterious, its orbit so elongated that it spends 11,000 years beyond the reach of any planet's gravity, closer to the stars than its sun it technically belongs to. Every one of these scattered objects is a fossil of planetary migration. Their strange tilts, their impossible distances, tell the story of a time when Neptune charged outward like a bull, scattering proto-worlds the way a bowling ball scatters pins. Some were lost forever into interstellar space. Some crashed into the inner planets and delivered the first oceans. The rest became the silent refugees, preserving in their chemistry the exact recipe of the solar nebula before everything got cooked, melted, or buried under continents. Touch one if you ever could, and you would smell the birth of the sun, faint traces of ammonia, carbon monoxide, the quiet perfume of a cloud that collapsed before fish learned how to swim. Stand at the farthest edge of the Oort cloud and look outward. The sun is no longer the brightest star. Proxima Centauri glows a sullen red just 0.2 light-years farther, close enough that its comets and ours sometimes trade places across the gulf. Here, the solar system has no border. Gravity thins to a whisper, then to nothing. Space becomes truly interstellar, colder than any cold on Earth, empty enough that a single hydrogen atom feels lonely. Yet even here, the past still travels. Light from the sun, weakened to a candle's flicker, keeps crawling outward at 300,000 kilometers every second, carrying news of a yellow star and 8 planets and one small world that learned to ask questions. That light will keep going for billions of years, growing fainter, redder, until it finally washes over some distant molecule and is absorbed, ending its journey the way every journey ends, by becoming part of something else. Behind it, the comets keep falling, the ice keeps cracking, the hidden oceans keep their secrets, and somewhere in the dark between stars, another cloud is collapsing right now, another star igniting, another set of worlds learning to spin. Maybe one of them will catch fire with life. Maybe one already has, and its first radio whisper is only now crossing the void towards us, traveling at the speed of light, but still centuries away from our trembling antennas. The story never closes. The night simply hands the pen to the next dreamer and waits, patient as starlight, for the next sentence to arrive. So breathe out. Let the dark feel soft. Somewhere out there, something is just beginning to shine, and it has been aiming for your eyes since before your grandparents were born. All you have to do is keep the window open.
Picture a world so small that all of humanity could stand on it shoulder to shoulder and still have room for every forest we ever burned. Pluto is that small, yet it carries secrets large enough to swallow entire theories. Its day is 6.4 Earth days long, so the sun, looking like a brilliant star, crawls across the sky with agonizing slowness, painting the ice in shades of rose and gold for weeks at a time. Across the western lobe of the Great Heart, Tombaugh Regio, lies Sputnik Planitia, a basin 3 miles deep filled not with rock or dust, but with soft, creamy nitrogen ice that behaves like glacial toothpaste. Convection cells the size of countries rise and fall over hundreds of thousands of years, carrying darker tholins from below and depositing fresh snow on top, erasing craters as casually as a child wipes fingerprints from glass. Beneath this frozen lid, models now insist, lies an ocean, perhaps 60 miles deep, insulated by a thick layer of gas hydrate clathrates that act like the universe's best thermos. The water is salty, laced with ammonia to keep it liquid at -370 degrees Fahrenheit, and possibly warmed by serpentinization reactions that release hydrogen, the same chemistry that feeds deep-sea vents on Earth. If life ever learned to breathe hydrogen instead of oxygen, it could be doing it right now, under Pluto's heart, in total darkness, never knowing the sun exists. High above, Charon looms like a second planet, its face forever locked, tidally scarred by chasms 8 miles deep, and a mysterious reddish polar cap that may be tholins stolen from Pluto's escaping atmosphere. Between them, the smaller moons dance in chaotic resonance, their rotations flipping unpredictably every few decades. No calm spheres, but wild spinning tops kicked by invisible tides. Even the air joins the performance. When Pluto nears perihelion, surface frost sublimates into a global haze that scatters sunlight into twilight halos and double sunsets. Then, as it recedes, the sky literally falls, nitrogen rain turning back into glittering plains, molecule by molecule, until the atmosphere is once again a frost sheet you could skate across. Pluto is not a dead relic. It is a slow-motion world where geology takes 1 million years to shrug, where chemistry dreams in the dark, and where every decade we discover another layer we never expected on something so small and so far away. It keeps whispering, size means nothing, distance means nothing. Even at the edge of the sun's reach, the universe still finds ways to surprise itself. Mercury is the solar system's blacksmith shop, hammered, scorched, and left to cool in the open air. Stand on its surface at local noon, and the sun is a bloated white monster 3 times wider than you've ever seen, glaring down with 11 times Earth's intensity, close enough that its prominences are visible to the naked eye. The ground beneath your boots is dark volcanic glass and powdered metal that reflects almost no light, so the heat slams into you like a physical blow. Yet turn around and walk just a few miles toward the terminator, and the temperature plummets hundreds of degrees in minutes. There is no air to blur the line, only raw starlight and raw darkness kissing across ancient lava plains. The Caloris Basin dominates one hemisphere, a bullseye 960 miles wide, ringed by mountains thrown up. When the impactor hit so hard, the planet rang like a bell. On the exact opposite side of the world, the seismic waves converged and shattered the crust into a surreal landscape of jagged blocks and hollows, the weird terrain, where hills stand on end like broken teeth. As Mercury cooled, it shrank more than 7 miles in radius, wrinkling its skin into lobate scarps, cliffs 2 miles high that slice straight through craters and plains as if a giant hand dragged a knife across wet clay. Some scarps are so fresh they still show bright rays, meaning they formed long after the heavy bombardment ended, while the planet's heart was still contracting. And its heart is enormous, an iron core 2,000 miles across, surrounded by a paper-thin mantle and a crust only 30 miles thick. Part of the core remains liquid, stirred by the faint warmth of radioactive decay, generating a dipolar magnetic field that should have frozen solid billions of years ago but stubbornly clings to life. In the permanent shadows of polar craters, temperatures never rise above minus 300 degrees Fahrenheit, and there, hidden from the furnace above, lie billions of tons of water ice delivered by ancient comets and preserved like treasures in a dragon's vault. Mercury is the ultimate survivor, baked, beaten, squeezed, and still keeping water, magnetism, and secrets in the hottest place a planet can live. Venus is what happens when a world forgets how to exhale. Wrapped in pearl-white clouds that look soft from space, it hides a surface where lead would run like water and compasses melt. The atmosphere is 96% carbon dioxide, 90 times denser than Earth's, pressing down with the weight of a submarine a kilometer underwater. Sunlight filters through sulfuric acid veils, scattering into a dim orange twilight that never changes. There is no day or night, only a perpetual coppery haze lit by lightning that flashes every few seconds somewhere on the planet. The ground is a mosaic of volcanic plains, coronae like giant spiderwebs, and tesserae, ancient continental plates crumpled when the planet tried and failed to develop plate tectonics. Radar maps reveal more than 1,000 major volcanoes, some larger than any on Earth, yet none have been caught erupting. Venus keeps its fire inside, resurfacing itself in sudden global spasms every few 100 million years, then falling silent again. Its rotation is the slowest of any planet, 243 Earth days for one turn, and backwards, so the sun rises in the west and takes 4 months to crawl across the sky. Meanwhile, the upper atmosphere screams around the planet at 220 miles per hour, completing a full lap in 4 Earth days, dragging acid clouds and heat in a super-rotating shroud no model fully explains. Once, billions of years ago, Venus probably had oceans. Then the sun brightened, water vapor filled the sky, and the greenhouse ran away. Temperature soared past the point where carbonate rocks began to break down, releasing still more CO2 in a feedback loop that cooked the planet dry. The last water molecules were split by ultraviolet light, hydrogen escaped to space, oxygen locked into the crust, and Venus crossed the threshold from temperate twin to infernal warning. Today, the surface glows dull red in the cracks between lava flows, and the air is so thick that a helicopter would float like a balloon while its electronics dissolved in minutes. Venus is Earth's ghost of Christmas future, beautiful, brilliant, and utterly unforgiving. From Pluto's frozen heartbeat to Venus's suffocating haze, the solar system is a gallery of extremes held together by the thinnest thread of sunlight. Mercury sprints and burns. Venus smothers. Earth somehow found the narrow path between them. Out past Neptune, Pluto keeps an ocean in the dark. Inside the orbit of Mercury, ice hides in eternal shadow. Comets carry the same water from one extreme to the other, stitching the story together with long white tails that only appear when they cross the invisible lines we draw. Every world is a question asked of the same original cloud. What survives fire? What survives ice? What survives time? The answers are written in lava that cooled before fish existed, in nitrogen glaciers that flow slower than continents drift, in an iron heart that refuses to solidify, in an atmosphere that forgot how to let go of its heat. And still, the probes keep coming. New horizons sailing past Pluto with fuel for decades more. Messenger diving into Mercury's gravity well to die in a deliberate crash. Magellan mapping Venus through its acid shroud, each one a fragile messenger from a species that learned to listen. Beyond the last scattered comet, the sun's light keeps traveling, growing fainter, redder, until it becomes just another photon in the cosmic background, undistinguishable from the glow left by the Big Bang itself. Yet somewhere that photon will land, on a distant ice grain, in an alien ocean, on an eye that has never seen our star but will still feel its ancient warmth. The solar system is not a place with borders. It is a conversation that began 4.6 billion years ago and has not yet decided what it wants to say next. So let the darkness settle gently. The planets keep their ancient rhythms, volcanoes sleep, oceans hide, and somewhere a new tale is silently forming in the dark, waiting for the right century to light the sky again. The story is still writing itself, one slow orbit at a time. All we have to do is keep listening.
Stand on the lip of Valles Marineris at dawn, and the canyon swallows half the sky. It runs a quarter of the way around Mars, longer than the United States is wide, deeper than the Mariana Trench stacked on itself twice. The walls glow rust red in the butterscotch light, layered like a cake that took 4 billion years to bake. Lava flows, lake beds, wind-blown dust, all frozen in time. Far to the west, Olympus Mons rises so gently that you wouldn't notice the slope if you stood on its flank. Only when you look back and see the planet curving away beneath you do you realize you're standing on a volcano tall enough to pierce Earth's jet stream 3 times over. Its caldera alone could swallow the entire big island of Hawaii. Yet it has been silent for 25 million years, its last lava frozen in black rivers that gleam like obsidian under the thin air. Trace the ancient valleys, Ninidi, Nergal, Ma'adim, and you follow rivers that once roared. Some were gentle streams that meandered for centuries. Others were cataclysms that emptied a sea the size of the Mediterranean in a single afternoon, carving channels wide enough to lose cities in. At the poles, layered ice caps rise in terraces like frozen wedding cakes, each layer a Martian year of dust storms and snowfall. Water ice, dry ice, dust, repeat, telling the climate story in stripes you can read from orbit. And everywhere, the wind sings. It has been polishing rocks and filling craters for so long that dunes march in perfect silence across the northern plains. Black sand made of volcanic glass, red sand made of rusted iron, white sand made of gypsum that once dissolved in vanished oceans. Mars is not dead. It is only sleeping so deeply that its breath is measured in millions of years. Somewhere under the permafrost, brine still seeps. Somewhere under the dust, microbes might still be dreaming of a wetter sky that will never return. The planet keeps its memories in stone and ice, and every rover we send is just another visitor reading the diary it never meant to leave open. Jupiter does not have weather. It has moods. Its atmosphere is an ocean of hydrogen 1,000 miles deep, striped in creams and caramels and blood reds, racing around the planet in jet streams that never slow. Every 10 hours, the entire world spins once, so fast that the equator bulges like a ball of dough flung on a potter's wheel. That spin is the heartbeat of everything. It twists the cloud bands into ribbons, squeezes storms into perfect ovals, and feeds the great red spot with the fury of a star that never quite learned to ignite. The spot is older than every telescope on Earth, older than the United States, possibly older than the Redwoods. It is a hurricane 3 Earths wide, spinning backwards to everything around it, its clouds moving so fast at the edge that the wind would rip the wings off any aircraft we could dream of. Yet at its center lies eerie calm, high pressure, warmer air, a crimson eye that stares upward into space and refuses to blink. Deep below the clouds, the pressure crushes hydrogen into liquid, then into metal, and the planet's own dynamo churns out a magnetic field that lashes space with radiation strong enough to kill an unshielded astronaut in minutes. Thunderheads taller than mountains rise and collapse in hours, flashing lightning 1,000 times more powerful than Earth's. Ammonia ice crystals glitter white. Ammonium hydrosulfide paints the belts in mustard and rust. And something, phosphorus, sulfur, complex organics dredged from the depths, dyes the great red spot the color of dried blood. That color waxes and wanes like a fever dream. Sometimes the storm shrinks, tearing itself apart in slow motion. Sometimes it deepens again, swallowing smaller vortices like a dragon gulping fireflies. Jupiter does not need the sun to stay alive. It radiates twice the heat it receives. A failed star that settled for being the undisputed king of worlds instead. Every storm, every band, every flash of lightning is the planet reminding the solar system that it is still growing, still restless, still dreaming of the day it might have burned. Saturn does not wear its rings. It is caught inside them. From a distance, they look solid, a perfect phonograph record etched in ivory and gold. But fly closer, and the illusion dissolves into a blizzard of moonlets, trillions of snowballs from dust grains to mountain-sized chunks, all orbiting in perfect synchrony. The main rings stretch half the distance from Earth to the Moon, yet are scarcely thicker than a house. Stand on one of the larger fragments, and you would see the others as bright sand grains suspended in black velvet, with Saturn itself filling the sky like a pale yellow wall brushed with delicate pastel bands. The rings are not eternal. They are a countdown. Shepherd moons like Prometheus and Pandora skate along the edges, carving gaps and braiding ripples that travel like slow waves on a frozen ocean. Inside the Cassini division, 3,000 miles of near emptiness, the gravity of little Mimas reaches in and clears the lane every time a particle dares to drift. Farther out, the faint G and E rings are made of ice grains sprayed from Enceladus's geysers, a misty halo that glimmers only when backlit by the sun. Every particle in the rings is a fossil of the early solar system, water ice so pure it shines like diamond, mixed with dark organic tar that fell in from interstellar space. Yet the rings are also newborn, perhaps only 100 million years old, the shredded remains of a moon that wandered too close or a comet that never escaped. They rain onto Saturn's equator in gentle dark streaks, a slow drizzle of ancient ice that will empty the rings in another few 100 million years. Saturn knows this. It keeps spinning anyway. Serene and unhurried, its butterscotch clouds sliding beneath the greatest jewel box the solar system ever made. The rings are not decoration. They are a promise written in ice. Everything beautiful is temporary, and that is why we cannot look away. Mars bleeds rust into its sky. Jupiter roars in silence. Saturn glitters like a secret someone forgot to hide. Between them all drift the small bodies, comets, asteroids, shattered moons carrying water, carbon, the quiet ingredients that once rained on every world and asked the same question: will you wake up? Only one world answered yes so far, but the question is still falling, molecule by molecule, across the dark. Every rover track on Mars, every photograph of Jupiter's storms, every close-up of Saturn's braided rings is a love letter sent to a future we haven't met yet. The planets keep their ancient rhythms, volcanoes that sleep for eons, oceans locked under ice, storms that outlive nations, and they do not care if we understand. But they let us watch. They let us listen. And somewhere in the long night between one orbit and the next, a new valley is being carved. A new ring particle is being born. A new ocean is shifting under its icy roof. The solar system is not finished telling its story. It is only waiting for the next pair of eyes quiet enough to hear the rest. So let the dust settle, let the storms keep turning, let the rings keep singing their thin, bright song. The night is patient, and the light that left Olympus Mons this morning is still traveling, looking for somewhere soft to land. It always finds us in the end.
Look closer and the rings dissolve into a blizzard of silent miracles. 99.9% of everything you see is water ice so pure it would shame the finest crystal on Earth, reflecting sunlight with an albedo that makes the ensemble glow like a halo no saint ever earned. The brightest parts, the B ring especially, are denser than steel by volume of particles, yet the whole structure is rarely thicker than a football field turned on edge. Stand inside it if you could survive the cold and the speed, and Saturn would fill the sky like a pale golden wall, its cloud bands sliding beneath you, while countless moonlets glint overhead like slow-motion snowflakes. Prometheus dips into the F-ring every 15 hours, its gravity twisting the narrow strand into braids and knots that unravel and reweave themselves over weeks. Pandora watches from the outside, keeping the whole ribbon from drifting away. Farther in, the Cassini division is not empty, but swept clean by Mimas dancing a 2-to-1 resonance, clearing its path the way a child's finger clears a groove in wet sand. Every gap, every ripple, every spoke that rises and falls across the rings like dark ghosts is a note in a piece of music written by gravity alone. When Saturn's 26.7-degree tilt carries it through equinox, the sun shines edge-on, and the rings vanish to a knife edge thinner than paper, revealing shadows of moonlets that look like tiny skyscrapers standing on a frozen lake. 6 months later, they blaze again, brighter than Venus ever dreams of being. And all the while, the rings are dying beautifully. Dark, organic rain from the outer rings falls onto Saturn's equator in gentle streaks, and micrometeoroids grind the ice into ever finer dust. In another 100 million years, maybe less, the greatest show in the solar system will fade to a faint ghost ring no telescope will notice. Saturn will still turn, serene and golden, wearing the memory of its jewelry like an old monarch who refuses to speak of lost youth. Until then,
The rings keep singing their thin, bright, impossible song, one that only gravity and light know the words to, and they are not telling anyone the ending. Imagine a god who tripped and never bothered to get up. Uranus rolls along its orbit like a barrel, poles aimed almost directly at the sun, so that for 42 Earth years, one hemisphere bakes in endless daylight, while the other freezes in decades of starlit night. At the summer pole, the sun circles the horizon without setting, a dull white coin in a featureless methane haze the color of antifreeze. At the winter pole, there is only starlight and the faint glow of Saturn's rings reflected off distant ice, enough to read by if you had eyes patient enough to endure. The collision that knocked it over must have been apocalyptic, an Earth-sized impactor slamming into a young ice giant, tilting the entire world 98 degrees and shattering its newborn ring system into the faint, charcoal-dark arcs we see today. That same blow probably vaporized an entire ocean's worth of water and ammonia, leaving a mantle of slushy fluid ices wrapped around a rocky core no bigger than a few Earth masses. 17 times Earth's mass, yet Uranus is the lightest of the giants, as if it exhaled most of its fury and never inhaled again. Its atmosphere is almost comatose. Winds barely reach 500 miles per hour, storms are rare and shy, cloud decks hide beneath a smothering haze of methane that drinks red light and spits back only blue-green. When Voyager 2 flew past in 1986, it saw almost nothing. A bland billiard ball with 13 coal-black rings and a family of dark moons that looked embarrassed to be seen. Yet beneath that calm, something still stirs. Seasons last a human lifetime. When spring finally arrives at one pole after 42 years of darkness, the sunlight wakes methane and hydrogen sulfide ices, brewing storms the size of continents that bloom and fade like time-lapse flowers. The magnetic field is a drunken corkscrew, tilted 59 degrees from the rotation axis and offset by a third of the planet's radius, as if the dynamo itself is still reeling from the ancient punch. Uranus is the quiet one at the family reunion, lying on its side, sipping its drink, watching the others spin upright and wondering why they bother. It has all the time in the world, 84 years for one lazy orbit, and it uses every minute to remind us that normal is just a temporary agreement most planets never signed. Neptune is the place where wind forgets how to stop. 4 times farther from the sun than Uranus, it receives 400 times less sunlight, yet its cobalt skin is lashed by gusts that would shred any storm on Earth, 1,300 miles per hour at the equator, fast enough to circle the globe in a day if the planet were small enough to notice. No one knows where the energy comes from. The sun is a bright star here, nothing more, yet Neptune radiates 2.6 times the heat it drinks, as if something inside is still furious. Its mantle is a diamond ocean, liquid carbon compressed so hard it crystallizes into gems that sink like slow rain through supercritical water and ammonia, releasing gravitational heat as they fall. That heat rises, punches through a hydrogen-helium atmosphere laced with methane, and explodes into storms that leave scars visible across 1 billion miles. The Great Dark Spot of 1989 was an anticyclone large enough to swallow Earth, its rim spinning so fast, clouds took only 16 hours to complete a lap, while the center floated in eerie calm. It vanished within years, replaced by another, then another. Neptune's storms are born screaming and die young, unlike Jupiter's ancient red spot that refuses to retire. High above, cirrus clouds of methane ice glitter at 50 miles altitude, catching the faint sunlight and glowing like blue fire against the deeper indigo below. Triton, stolen from the Kuiper Belt, circles backwards, spraying nitrogen geysers that catch the solar wind and paint a faint auroral ring around its captor. Neptune's color is the purest azure in the solar system, deeper than any Earth sky, because methane drinks red and spits back only the bluest light left.
Stand on its cloud tops, if you could, and the wind would tear the sound from your throat before you ever heard yourself scream. Yet the planet itself is serene, turning once every 16 hours, its voice a low, constant roar that never needs to shout twice. Neptune is the last of the giants, the farthest, the wildest, the one that took everything the sun had to give and decided it still wasn't enough. It sings in a register no one expected, and the song has not ended yet. At the center of everything burns a sphere of plasma so dense that a spoonful would weigh as much as a mountain, yet so hot that gravity itself struggles to hold it together. 15 million degrees at the core, hot enough to strip atoms naked and slam their nuclei together until 4 hydrogens become 1 helium, and the missing mass turns into light. Every second, 620 million tons of hydrogen die to keep the sun alive. And the energy released takes 1 million years to crawl outward, ping-ponging between particles in the radiative zone like a rumor in a crowded room. When it finally reaches the convective zone, it boils upward in continent-sized cells, plasma rising and falling in slow motion, carrying the heat that will one day become a sunrise on Pluto. At the photosphere, the temperature drops to a mere 5,800 degrees Celsius, cool enough for atoms to hold on to electrons again, and the sun becomes visible, a perfect golden disk, granulated like orange peel, scarred by sunspots where magnetic fields choke the convection and leave dark bruises that last weeks. Above that, the chromosphere flares pink during eclipses, a forest of spicules shooting up like burning grass. And beyond, the corona, a 1 million-degree ghost that should not exist, stretches millions of miles into space, hotter than the surface it abandoned, threaded by magnetic loops big enough to swallow Earth without touching the sides. From those open field lines escapes the solar wind, a breath of protons and electrons that fills the solar system and shapes every magnetosphere from Mercury to the heliopause. The sun is not gentle. It lashes out in coronal mass ejections that can strip atmospheres and fry satellites. Yet it also shields us. The heliosphere is a bubble of solar fire that keeps cosmic rays from sterilizing the inner worlds. Every photon that warms your face this morning was born before the pyramids, fought its way through 200,000 miles of stellar hell, and leapt into space 8 minutes ago, just to die on your retina. The sun remembers nothing of the journey. It only keeps burning, turning 4 million tons of itself into light every second, asking no applause, keeping no score. And when it finally exhausts its hydrogen in 5 billion years, it will swell into a red giant, swallow Mercury, Venus, maybe Earth, and then collapse into a white dwarf no larger than our planet. Quiet at last, cooling for trillions of years in a universe that will have forgotten it ever shone. Until then,
Deep inside the sun, where pressure crushes atoms like forgotten promises and temperatures rage hotter than any furnace humanity could dream, something alchemical happens. 4 hydrogen nuclei, simple protons, the lightest things that matter, slam together in a dance of repulsion and inevitability. They fuse, shedding a fraction of their mass, and in that tiny sacrifice, Einstein's quiet equation awakens. E equals mc squared. That lost mass becomes pure energy, a flood of photons born in the core's blinding heart, each one carrying the power to cross the void and warm a distant world. But the journey is no sprint. These photons zigzag through the radiative zone, a labyrinth of plasma denser than lead, bouncing off electrons and ions in a drunken walk that lasts 100,000 years or more. Every collision absorbs and re-emits them, dimming their fury, until they reach the convective zone, a roiling sea where heat bubbles up in vast cells, plasma rising like dough in an oven, cooling at the top, then plunging back to be reheated.
Here the energy surges outward in turbulent loops, carving the path that will become sunlight. Finally, it breaks free at the photosphere, the sun's visible skin, a granulated frontier where convection cells etch patterns like boiling rice, each granule a Texas-sized updraft that lasts only minutes before collapsing. From there, the light leaps into space, 8 minutes to Earth, carrying the echo of that ancient fusion. Yet this is no mere bonfire. In larger stars, the process escalates. Heavier elements forge in layers, helium to carbon, carbon to neon, neon to silicon, until iron halts the chain and the star collapses in supernova fury, scattering gold, uranium, the stuff of planets across the galaxy. Our sun is modest, a yellow dwarf destined for a gentler end. In 5 billion years, it will puff into a red giant, its fusion spent, shedding outer layers like autumn leaves to leave a white dwarf, ember, cooling forever. But for now, it is the architect of everything. Every leaf that turns toward it, every ocean wave that catches its gleam, every thought fired in a brain made of stardust it helped create. Nuclear fusion is the universe's patient sculptor, turning the simplest gas into the complexity of worlds, reminding us that the light on your window this morning was forged in a place no eye will ever see, from mass that chose to become something infinite instead. Imagine the sun's surface not as a flawless orb, but as a canvas scarred by shadows that twist and grow like living ink. Sunspots emerge from the depths, cooler patches where magnetic fields coil like invisible springs, suppressing the usual boil of convection and dropping temperatures to a mere 4,000 degrees Celsius, still hot enough to vaporize rock, but dim against the surrounding 5,800 degrees Celsius blaze. Some spots are solitary freckles, others cluster in vast archipelagos spanning 50,000 miles, large enough to swallow Earth a dozen times and still have room for the moon. They follow the sun's 25-day equatorial spin, marching across the disk in pairs of opposite polarity, north and south magnets linked by loops that arch into the corona like bridges no one can cross. Beneath them, the tachocline, a shear layer where the rigid core meets the fluid outer zones, twists the magnetic field into ropes, amplifying it until it bursts through the photosphere in these dark heralds. And when the fields snap, the drama unfolds. Solar flares ignite in seconds, releasing energy equivalent to billions of hydrogen bombs, hurling X-rays and ultraviolet bursts that ionize Earth's upper air, blacking out shortwave radios and swelling the atmosphere to drag satellites low. Coronal mass ejections follow, billion-ton clouds of plasma erupting at 1,000,000 miles per hour, threaded with magnetic fields that twist space itself. These ejections carve through the solar wind, a constant breeze from the corona, and when they slam into Earth's magnetosphere, they compress it like a squeezed balloon, injecting particles that spiral down field lines to paint the auroras in emerald and violet veils. Sunspots are the sun's temper tantrums, reminders that our star is no passive lamp, but a magnetic beast whose moods ripple across the system, disrupting GPS for pilots over the ocean, inducing currents that could fry power grids in a repeat of the 1859 Carrington event when telegraphs sparked and auroras lit the night as far south as Hawaii. Yet they are also creators. Those same particles fertilize the ionosphere, enabling long-distance radio bounces that connected the world before satellites. Sunspots wax and wane, mapping the star's hidden dynamo, teaching us that even the brightest light carries shadows deep enough to touch us from 93 million miles away. When the sun unleashes a flare, it is like a dragon stirring in its sleep, sudden, brilliant, and gone in minutes, but the roar echoes for days. These eruptions stem from tangled magnetic fields around sunspots, where energy stored over weeks releases in a flash, accelerating electrons and protons to near light speeds in loops taller than Jupiter. The radiation spans the spectrum: gamma rays that could sterilize a planet if close enough, X-rays that heat Earth's ionosphere like a microwave, causing it to puff up and disrupt high-frequency communications for aircraft crossing the poles. Ultraviolet light follows, exciting atmospheric molecules to glow faintly, while radio bursts jam signals like static from a cosmic storm. 8 minutes to Earth, no warning possible. Pilots lose contact mid-Atlantic, GPS glitches throw ships off course by miles, and astronauts on the ISS huddle in shielded modules as proton storms rattle past. But flares are mere sparks compared to coronal mass ejections, vast bubbles of plasma, 10 billion tons heavy, blown from the corona like smoke rings from a giant's pipe. They expand as they travel, engulfing planets in their path, their embedded fields reconnecting with Earth's in a geomagnetic tango that funnels particles to the poles. There, oxygen and nitrogen atoms collide with the intruders, shedding energy as light. Green from oxygen at 100 miles up, red from higher altitudes, purple from nitrogen, draping the Arctic and Antarctic in curtains that shimmer like silk in a breeze. During intense storms, auroras dip to mid-latitudes, seen in Florida, Mexico, even the equator in rare Carrington-level events, while on the ground, induced currents surge through pipelines, railways, and grids, melting transformers and blacking out millions, as in Quebec's 9-hour darkness. Satellites age prematurely, their solar panels pitted by high-energy protons, electronics glitching in the radiation bath. Yet this fury nurtures too. The same particles seed clouds in the upper atmosphere, perhaps influencing weather patterns over decades, and the magnetosphere's compression reveals its shape, teaching us how our invisible shield guards life from the galaxy's harsher rays. Solar flares and CMEs are the sun's wild poetry, destructive verses that could end our wired world in a day, yet beautiful enough to make us stare skyward, wondering at the fragile thread connecting our quiet nights to a star's restless heart. Every 11 years, the sun inhales and exhales. Its magnetic soul flips poles in a rhythm older than life on Earth. At solar minimum, the star slumbers. Sunspots fade to whispers, flares are rare whispers, the corona a smooth helmet with holes at the poles, spewing fast solar wind that barely ruffles the heliosphere. Space feels emptier. Cosmic rays from distant supernova slip through easier, pummeling astronauts and high-altitude flights with extra radiation, while Earth's upper atmosphere cools and contracts, letting satellites orbit longer without drag. Then the cycle awakens. Magnetic fields wound tight by differential rotation, the equator spinning faster than the poles, emerge as new sunspots near the mid-latitudes, marching equatorward like migrating birds. By solar maximum, the photosphere bristles with spots, each a gateway to chaos. Flares erupt daily, CMEs barrel outward weekly, geomagnetic storms rage monthly. The corona blooms into a jagged crown, slow wind from equatorial streamers clashing with fast polar gusts to create shock waves that accelerate particles to lethal speeds. Earth feels the pulse. Auroras blaze more often, power grids hum with induced currents, airlines reroute polar flights to dodge radiation spikes that could add a year's dose in hours. GPS signals scatter, oil pipelines corrode fast.
Every 11 years, the sun stirs from its slumber, its magnetic veins twisting and untwisting like a sleeper turning in a dream too vast to wake from. At minimum, the photosphere is almost serene. Sunspots, scarce as forgotten promises, flares, rare whispers that barely ripple the solar wind. The corona streams fast and steady from the poles, a gentle breath that lets cosmic rays sneak closer, peppering high-flying jets with extra doses of radiation, making pilots glance at their instruments with quiet unease. Earth's outer atmosphere shrinks in the cool, satellites glide higher without the drag of swollen air, and auroras fade to faint glows over polar ice, like embers banked for a long night. But as the cycle climbs, the dynamo deep in the tachocline winds tighter, magnetic fields buckling under differential spin, the equator racing ahead, poles lagging like reluctant dancers. Sunspots bloom near 30 degrees latitude, dark umbras ringed by penumbral filaments that twist like smoke, each pair a north-south magnet announcing the coming storm. By maximum, the sun is alive with fury. Spots cluster in active regions, their fields reconnecting in explosive snaps that birth flares brighter than 1 billion suns for moments. These bursts flood space with X-rays, heating Earth's ionosphere until it bloats, scattering radio signals so transatlantic flights lose contact mid-ocean, GPS wavers for surveyors in remote fields. Coronal mass ejections swell next, vast plasmoids erupting like volcanic plumes, carrying helical fields that crash into our magnetosphere days later. The bow shock compresses, particles funnel to the cusps, exciting oxygen to green veils and nitrogen to purple ribbons that dance over Alaska or Norway, visible even in Tokyo during monsters like 2003's Halloween storms. But beauty hides peril. Geomagnetic-induced currents snake through power lines, overheating transformers as in Sweden's 2003 blackout, corroding oil pipelines in Alaska's permafrost. Astronauts on the ISS shield behind water walls as proton storms rage. High-altitude passengers over the poles absorb radiation equivalent to a chest X-ray in hours. The ozone thins under UV assault, atmospheric chemistry shifts, perhaps seeding clouds that alter rainfall patterns over continents. Scientists watch from SOHO's halo orbit, SDO's geosynchronous perch, tracing the polarity flip, fields reversing like a cosmic breath inverting. This Hale cycle, full every 22 years, influences not just tech, but life. More UV tans skin, but raises melanoma risks. Expanded atmosphere tugs satellites low enough for unplanned re-entries. Yet in the waning, as spots migrate equatorward and fade, peace returns, a reminder that the sun's rhythm is our rhythm. Its maximum, a wake-up call to our fragility. Its minimum, a lullaby whispering that even stars need rest. The cycle turns onward, unconcerned, shaping the invisible weather that bathes our blue world in equal parts wonder and warning. A heartbeat we feel but cannot touch. From mountain peaks and orbital perches, we steal glimpses of the sun's secrets, tools forged from glass and silicon to pierce a veil no naked eye could survive. On Haleakala Summit in Hawaii, the Daniel K. Inouye Solar Telescope stands like a sentinel, its 4-meter mirror, the largest ever for solar gazing, capturing light with adaptive optics that bend and flex 1,500 times a second, countering the atmosphere's shimmer as if parting a curtain over a boiling sea. It reveals sunspots in exquisite detail, umbral cores dark as coal, penumbral threads like wheat fields bent by wind, magnetic flux ropes twisting upward to spawn prominences that hang like fiery arches over the limb. Granules churn below, each a plasma updraft wide as France, rising and falling in 5-minute lives that paint the photosphere's texture. In space, the Solar Dynamics Observatory orbits Earth in sync, its instruments slicing the spectrum into 10 wavelengths, from extreme UV that traces million-degree loops to visible light, showing cool factally brightening the disk. It catches flares mid-burst, their ribbons crawling across active regions like lightning frozen in amber, and maps magnetic fields with Zeeman splitting, revealing how they braid and snap to launch CMEs, those billion-ton bubbles that swell and twist towards us. SOHO, parked at L1 a million miles sunward, watches uninterrupted. its coronagraphs blotting the disk to expose the corona's pearly glow, streamers flowing equatorial like a lion's mane, and holes at poles spewing fast wind that carves the heliosphere. It detects CMEs hours early, halo events blooming toward Earth like ominous flowers. Closer still, Parker's solar probe dives into the corona itself, skimming 4 million miles from the surface at 430,000 miles per hour, its carbon foam shield glowing cherry red against 2,500 degrees heat, while instruments sip the solar wind, tasting alpha particles and tracing switchbacks, magnetic zigzags that accelerate the flow. Solar Orbiter complements its elliptical path, carrying it over the poles for first-ever views of those uncharted latitudes, high-res images showing campfires, mini flares flickering like embers in a dying fire, and measuring fields that heat the corona to millions of degrees, a puzzle where the atmosphere outshines the surface below. Together, these eyes weave a tapestry, ground scopes for sharpness, space for clarity, probes for intimacy. They predict space weather like meteorologists forecast rain, flares disrupting drone swarms over cities, CMEs threatening grids during global events. Yet they also unveil beauty, prominences curling like dragon tails, coronal rain falling back in golden droplets. Humanity's gaze turns the sun from distant god to intimate companion, its data shielding our wired world while whispering of mysteries still hidden in the plasma's roar. A star we study not to conquer, but to understand the fire that birthed us all.
In the velvet quiet of a clear night, the moon begins its monthly masquerade, a silver chameleon shifting shapes in a cycle as reliable as the tide it commands. It starts invisible, a new moon lost in the sun's glare, aligned perfectly between us and our star, its far side bathed in light, while the near face hides in shadow, a blank canvas waiting for the first stroke. Days pass, and a waxing crescent emerges low in the west after sunset, a delicate arc like a bowstring drawn tight, sunlight grazing the limb to reveal craters like Tycho's rayed splendor, while the rest glows faintly in earthshine, our planet's reflected blue casting a ghostly pallor on the dark Maria. The crescent fattens nightly, horns pointing south in the northern sky, until first quarter. Half illuminated, a perfect semicircle rising at noon and setting at midnight, Terminator slicing straight down, highlands bright and rugged on the lit side, Sinus Iridum's bay curving like a pearl in oyster shell. Here the play of light and shadow peaks. Craters deep as canyons throw long spikes at dawn, mountains like the Apennines standing sharp against the void. Then waxing gibbous swells, more than half lit but not quite full, gibbous from the Latin for humpbacked, the moon bulging toward wholeness, Maria like Oceanus Procellarum spreading ink black across the face, volcanic plains frozen billions of years ago. Suspense builds as the Terminator creeps eastward, revealing more until the full moon rises at sunset opposite the sun, its entire disk a blazing lantern, washing the landscape in monochrome silver that erases colors and sharpens edges, owls calling louder, tides pulling highest in Syzygy's grip. Craters flatten in the overhead light, but rays from young impacts streak like comet tails, Aristarchus glowing blue-white. Waning gibbous follows, the light retreating westward, the hump deflating as shadows reclaim the east, last quarter mirroring the first, but reversed, half-lit rising at midnight, Terminator now on the west, setting at noon. The waning crescent thins to a sliver in the east before dawn, horns now pointing north, a fragile smile fading into twilight, Earth shines stronger as our world waxes in the moon's sky. Then back to new, the cycle complete in 29.5 days, synodic rhythm syncing with solar alignment. This dance has marked time for eons, farmers planting by waxing light, sailors navigating by its height, cultures weaving myths of goddesses and rabbits etched on its face. It tugs at oceans, influences moods and subtle pulls, reminds us of celestial mechanics' grace. Not the moon changing, but our vantage on its eternal half-light,
a monthly poem written in phases, inviting us to look up and feel the quiet pull of something larger turning in the dark.
Long before life stirred in Earth's primordial seas, a rogue world named Theia, Mars-sized, restless in the young solar system's chaos, hurtled toward proto-Earth on a path of destiny and destruction. 4.5 billion years ago, it struck a glancing blow, not head-on, but at an angle that vaporized both mantles in a cataclysm of molten rock and superheated gas, the impact energy rivaling 1 trillion Hiroshima bombs. Earth's iron core absorbed Theia's, swelling our planet slightly, while the debris, silicates and volatiles blasting into orbit, formed an incandescent ring around the wounded world, glowing like a forge fresh from the hammer. Gravity took hold in hours, particles clumping into moonlets that smashed and merged over months, accreting into a single body still molten from the violence. Its surface a lava ocean deeper than Earth's crust is thick. This giant impact hypothesis explains the moon's quirks. Its rock, so like Earth's mantle in oxygen isotopes, depleted in volatiles that boiled away in the heat, enriched in refractory elements that survived the fire. The tilt of Earth's axis, wobbling from the off-center hit, birthed seasons that would one day nurture diversity. Alternatives whisper from the sidelines, the capture theory, where the moon formed far out and wandered into Earth's grasp like a stray comet, but it falters on the isotopic match, too coincidental for separate births, and struggles with the angular momentum needed for stable orbit without a braking mechanism. Fission posits a spinning Earth so fast it flung off a blob of mantle like clay from a potter's wheel, but calculations demand a rotation every 2 hours, implausible without a lost companion to speed it up. Co-formation sees them as twins from the same disk, condensing side by side like siblings in a stellar nursery, yet it cannot square the moon's iron-poor heart, barely 1% core versus Earth's 30%, nor the density drop that hints at a stripped origin. Theia's ghost lingers in simulations, vaporized rock condensing into a synestia, a donut of gas and melt, where the moon coalesced off-center before settling in. Lunar samples from Apollo bear the scars, basalts from ancient seas, anorthosite highlands floating like scum on cooling magma, all dated to that fiery dawn. This birth bound us eternally. The moon's pole slows Earth's spin, lengthening days from 6 hours to 24, stabilizing our tilt against chaos that would swing poles to equator. It drives tides that mix nutrients, perhaps sparking life in shallow pools. Yet the story evolves. Recent models suggest multiple impacts, or Theia as a Trojan sharing Earth's orbit before collision. The moon hangs as evidence, a scarred witness to violence that gifted stability. Its origin, a tale of destruction birthing beauty, reminding us that creation often rises from ruin, and the quiet orb above still carries echoes of a shattered past, waiting for our next probe to whisper more.